Okay, guys, let's get started here. We're going to do part 2 of quadratics. So let's hop right back in here. Yesterday we focused on the idea of functions. Think of a function as a machine. If I plug in the value of 2, if it is truly a function, I should only get back one answer. Right? 2 should give 5, not 5 and 7 and 9, because how do we know which one's the right one? Right? So the functions you guys know then are linear and quadratic. Essentially something like y equals 3x plus 4. That's linear. That's what you did last year, a nice straight line graph. Yesterday we started introducing the idea of quadratics, like y equals 3x squared plus 2x plus 1 might look like that-ish. So today I just want to talk about a few more details about what these two kinds of graphs, what they might look like. So, before I get too far though, I just want to recap the idea of input versus output. If I give you f bracket 14.7, what that means is take your graphing calculator and find when x is 14.7. Go right here to 14.7 on the graph and find what the y value is. I mean, honestly, it's one of the easiest things to do, right? You just go, take your equation, whatever equation you have, find the value when x is 14.7. If I press enter right now, though, what do you think is going to happen? Why will it give me an error, though? I mean, is there a value for 14.7? Probably, but I bet you my window size doesn't go far. Okay. So that's one way of asking a question. The other thing I might ask is, well, what happens if x is 2.35? Well, in an example like this, it's more like you're putting a line across here and trying to go back down. So that's where you'd say put a new graph at 2.35. And then which one of these tools here can help you find it? Good. Okay, you guys seem to have that. Okay, so let's try an example then. This is very similar to on either assignment, -1 or -2, the very, very last question. It's more of a word problem. So let's give one a try as a group here. A diver is going to jump from a 3-meter springboard with an initial velocity of 6.8 meters per second, and we've graphed the diver's height according to this equation here. So really the first thing I can do then is take that equation and plug her into the graphing calculator. I'm just going to get rid of all the old ones. I probably don't need them anymore. Okay, now one thought here. This equation here is not y equals with x's, it's h's with t's. But it's the same thing, right? Yeah, right? So your t is now going to be your x, and your h is going to be your y. That's all. So y equals, here we go, negative 4.9. Physics kids? Half of gravity, by the way. 4.9, half of gravity, just in case you're wondering where that came from. X squared plus 6.8 x plus 3. And the advice I might give before you just blindly press graph is let's consider our window size before I press graph.
I didn't.
All right, well, let's say you don't. That's not a bad graph. But if this were me marking yours, I wouldn't give you full marks for that because this is not really the whole graph of what we're looking for. In a word problem context, can this person have negative time? That doesn't really make sense, does it? What about negative for the y value? Could it be negative y values? What's happening here? This girl's jumping off of a springboard. Okay, I guess she could go below the surface of the water. That would make sense. But maybe I should use this whole graph. Maybe I should change my window and say, well, let's go from 0, because I can't have negative x's, right? And as I looked at my graph there, you know how I was wasting a lot of space on the one side? Let's not go from 0 to 10. Let's go from 0 to 5. But something smaller than 10. 10 was way too much, right? And then in the y value, well, maybe I'll just graph it right now and see where we're at. That's not bad. But is she really going to go that far underwater? Or is that going to be a little unnecessary? And do we really need this area way up here that's not being utilized? So let's make a few more shifts. Let's go from, say, negative, maybe negative 2. She can go underwater a little bit. And then we don't need to go as high as 10, maybe as high as 7. You know what? Although that's getting to be a better graph, I still have a lot of wasted space, don't I? I'm going here, like way over here. Don't I have a bunch of wasted space still? So I'm going from 0 to 5. Maybe rather than going to 5, I should go to 3. Sure, let's try 3. Yes. Yeah, that's better. Honestly, I think 2 would have even been acceptable as well. Why don't I go 0 to 2? Now, there's no right answer as to what you use for your window size, but there is a wrong answer. I can phrase it that way. You could have gone from 0 to 3, I'd be fine with it. You could have gone from 0 to 2, I'd be fine with it. But if you went from 0 to 400, that's not smart. You know what I'm saying here? So there isn't necessarily one right way of doing it, but you definitely can make a graph that's kind of silly. So this now to me looks like a good graph. So let's graph this according to the way that I expect a graph to be drawn. So maybe something like this. And yeah, good enough. That is my expectation of your graph. Well, to start with. Okay, I need to do a couple other things. I need to tell you your range from what you're working with, right? So my window is going from 0 to 2. And in the other direction, it was going from -2 up till 7. So far, so good? We're going to start answering some of the word problem questions that go with it. What's the y-intercept represent? Well, before we get to that, let's find what the y-intercept is. Second, calculate the value when x is
Starting point.
Yeah, it's your starting point. It was at 0 and 3, which I think makes a whole lot of sense because the person was diving off of a 3-meter diving board. Makes sense, doesn't it? Yeah. The starting point was 3 meters in the air. I mean, literally, that's all I need here. What does the y-intercept represent? Where the person started, 3 meters up. Next question, where's the maximum height of the diver? Well, the maximum height of the diver, we should be able to calculate that on our calculator using the maximum function, right? Sorry, I'm being kind of facetious here. Maximum function. Hopefully you guys kind of know how to use that by now, right? So the maximum, it doesn't really matter where you are on the left or right, but you do have to narrow down kind of a search radius. Don't forget to press enter through the guess. You don't necessarily have to move the cursor exactly right on the maximum unless there's more than one maximum location, but don't forget to press enter one more time. Anybody else get those numbers there if you can see them? Yep. 0.693877 and 5.359. I don't really care what you round it to. Why don't we say though, like always round it to like either like the 10th or the 100th. Like don't call this number 5. That's probably not enough decimal places. But whatever you round it to, let's plot it on the graph here. This value is 0.69, let's call it. And 5.36. I don't care what you round it to, just round it appropriately. Well, if I ask you how high the diver reached, which one of those numbers is how high she reached? No, the 5.36. Because that's the y value is the height value. That makes sense. For the second half of the question, though, when does she reach that height? Yeah, after 0.69 seconds. After 0.69 seconds, that's how high the person is in the air. Where is the location where they hit the water? The x-intercept, right? Here's a few ways of finding an x-intercept. You could go second table and look for where the y value is 0. I don't see where it's equal to 0 here, though, so there is another way of doing it in your calculator. Go second, calculate the 0. How does this guy work? Yeah, it's more or less the same as the max minimum, right? You have to put this thing above And I'm just going to have to press over quite a bit. I have to make sure that this cursor crosses that axis. There you go. Somewhere in there is a x-intercept. I could put the cursor close to it, but since there's only one of them, it should auto-find that one. Yes. Here we go. Okay, hopefully you can see that a little bit. I got 1.73, 1.74. Did anybody else get something like I did here, though, where it didn't say 0, it said like 1e negative 12, or something silly like that in the y spot? I got it. You got a 0 on yours? Anybody else get something like this, though? Especially if you have like one of the older calculators?
Let me just see.
Okay. 1e negative 12, just to remind you guys how that works, is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what 1e negative 12 is. Again, your calculator to find this uses some pretty complicated calculus. And once in a while, if you have an older brand calculator, it will say that this value is something kind of strange. This is essentially the number 0. That makes sense. So if you see something funny like 1e negative 12, 1e negative 15, 1e negative something like that, don't stress, it's 0 essentially. So this value here is at 1.74 and then 0. So to answer the question, when does the diver hit the water? 1.74 seconds. That makes sense. Let's do the domain and range. Of this entire graph, normally we'd say the domain is x is an element of the reals. But not on a word problem. Because can we have negatives for time? Does that really make sense? No. And I don't think we should use a time value of 7 or 8 or 9 seconds because I don't think that the person's going to keep going underwater for forever. So here's a different way of answering domain and range. Your domain is usually, and your range gets written in this sort of format where x and y are between certain values. Or like x is in the middle of a couple of numbers. This number right here will be the lowest number x ever reaches. And this number over here will be the highest number x ever reaches. This number over here will be the lowest number y and the highest number for y. So now look at our graph and try to figure out, well, what's the lowest number for x that's kind of logical? Yeah, wouldn't it be 0? Doesn't it start right here at 0? And why don't we end it when the person hits the water? Then the highest that this person ever gets to is about 1.74, because that's when they hit the water. Assuming they don't, I know they go underwater, but we end it there. That would be good if it just smashed in the water. What about for your y value? What's kind of the lowest value for y we probably should go with? What do you say? Well, although I guess they went down to -2 here, wouldn't you agree though that if we stopped here at 1.74 when they hit the water, isn't the lowest value, at least at that point, 0? We could go down to -2, but it just means we'd have to change this number then. So if we're kind of stopping right here, if this is the stop point right there, then the lowest we seem to get down to is 0. Well, then the highest we get to is 3, right? It's not 3. So I want to point out a mistake here. Don't just look at the starting value of 3, because they didn't get a little higher. The highest they got to is 536. So in the frame that we were kind of considering, in this sort of frame right here, lowest is 0, highest is 174. And in the y direction, lowest is 0, highest is 536. So that would be a good example of where domain and range, they sometimes change a bit. Last one. Let's say I wanted you to find the height of the diver 0.6 seconds after leaving the board. Well, all you got to do is find the value after 0.6. 5.316. That makes sense? All you got to do is just do the value on your calculator and it'll find out, well, when she was at 0.6 seconds, that's how high she was. That makes sense. both of you guys in -1 or -2, doesn't matter which class you're in, both have a word problem at the end. I know the word problem has like parts A, B, C, and D, but hopefully you'd agree it's very similar to this one right here. It doesn't actually take that long. You're just solving for different characteristics like the start, the finish, and the maximum. You just have to try to find those values. That's it. Does that work? Okay. Let's talk about a few other things here before I end this lesson. In terms of solving, if I ever ask you to solve, solve means look for the values of x. If it's equal to 0, the y value is 0, you can still use the quadratic formula. If you're in -2, I'm not going to make you do that anymore. We've covered our quadratic formula stuff, we're done with that. But in -1, I could actually still ask you to use the quadratic formula to find where the answers are. Because don't forget, there could be 2 answers, 1 answer, or there might not even be any x-intercepts. So I just want to remind you, there is a big overlap between the algebra and this section here. But if you're in -2, we won't pull the quadratic formula back out again this year. Okay, new thing I want to talk about here. That vertex. That vertex is a really important point. It's essentially the lowest or highest point on the graph of the parabola. And so sometimes we label it using a certain set of letters. We sometimes use H and K. I don't know who decided to go with H and K rather than A and B or Z and Y, but it's kind of a convention. Sometimes you may see a textbook use P and Q. I don't really care what letters we use, but we sometimes label them with generic letters. And I have a really important reason why in a bit. But we're going to focus today on this vertex. There's actually a couple different ways of writing a quadratic equation. The first one is what you guys have been working with so far. It's called standard form, where you just kind of write it out in, 3x squared plus 4x plus 7. That's a regular old-fashioned way of writing a quadratic. But there's actually another way that we often write them, and it's called vertex form. And the reason why it's written in this format is that I can tell you where the vertex of the graph is, and I don't even need a graphing calculator. If you write it in this format, a bracket x minus h all squared plus k, whatever this number and this number here is, that is your vertex. I'm going to show you guys some examples to help illustrate how this works. So this is kind of a nifty trick that's kind of useful. Let's graph this equation. X minus 2 squared plus 1. Do you see how this is written in kind of a strange format? It's not written all out like all your x squareds, then your x's, then your constant terms. It's not written in standard form. It's written in kind of a funky form. We call that form vertex form. Well, watch how this works here. Once I graph this, I'm going to go to a zoom standard, by the way. Let's find that vertex. This time it's a minimum, right? Because it's the lowest value. Check out the minimum value I got. Ignore the fact that my calculator is a little strange and it gave me 215. This value right here is really 2 and 1. Well, if your quadratic is written already in the vertex form, see how there's a 2 right here? See how there's a 1 right here? If it's written in that format, you don't even need your graphing calculator to find the vertex. You'll just know what the vertex is because you can find these values right here. You just need to know the rule for how it works. The format looks like this. Y equals a leading coefficient, x minus equals h squared plus k. In this graph right here, what is this a value up front? Yeah, it's 1 actually, because I didn't write anything there. Now, the way this works is that this number right here has to be a negative number. So it has to be negative. Since it was x minus 2, the minus 2 actually makes this coordinate here positive. So essentially you have to take the value that's here, you have to flip it. If it's negative, it's actually positive 2. So if this was x plus 2, you'd make it negative 2. So the value inside the brackets, just flip its plus minus sign. The value after the brackets is just whatever it is. And that'll find you the vertex, like that, which is kind of a nifty trick. So I'll come back to that slide. Let's try another one here. I don't even want you to graph it. Tell me where the vertex will be. Is this in the vertex form we need? Yeah, based on this guy right here, it's going to be at -1 because you flip that sign. And that one's -1, so you leave it at -1. I know where the vertex is without even having to do any work on my calculator, which is kind of a nifty trick. The thing, though, is it has to be written in the appropriate vertex form. That's all. So if it's not written in that format, it doesn't help. You know what I'm saying? Okay, let me talk a bit more about the leading coefficient again. This value right here of 2, that value there of 2 controls a couple of things. Essentially, it controls your slope. Remember how last day, though, I told you that when you learn the word slope, we really should use a more broad term. We call it a leading coefficient. Okay? If it's a positive value, it means that you have a sort of happy face kind of graph. But if that value was negative, you'd have a like kind of frowny face sort of graph. So just by looking at the equation, you guys should know roughly what the graph looks like without even needing a calculator. I should look at this graph and say, well, I know its vertex is -1 and -1. So I'm going to plot that right here. -1 and -1 is right about there. And based on this 2 right here, I know that it is a smiley face graph. This graph should look something like that. I don't even need my graphing calculator to know that. I should be able to rough it just by looking at the equation. Does that make sense? If I want to, I can go to the graphing calculator and type it into bracket x plus 1 all squared minus 1. But hopefully you agree. Isn't that essentially what I kind of drew there? So today is kind of me showing you a couple of tricks that's useful to help save you some time. Rather than have to type the graph in, key condition here though, if it's in vertex form, it has to be in that format, then you should be able to find things a little bit faster than using your calculator. So here I'll look at a couple of graphs I've got here. Here's the graph of x squared. Here I've got a graph of -2 x minus 3 all squared plus 1. I'll write it nicer so you can see. -2 x minus 3 all squared plus 1. I don't even need a graphing calculator. The negative makes it upside down. The 2 makes it kind of steep, that's all. The -3 means my vertex is at +3. And the +1 means my y-intercept is at +1. So this was actually kind of brilliant. Whoever managed to figure out how to write it in this format, because it's a time saver. Right? And that's why I'm showing this to you now as a way to help save you some time. So when you guys look through your assignment and you have to graph certain things, you can use your graphing calculator. And if you already have, I mean, just leave it, right? But double check. If it's in that format, that saves you a lot of time. So here's kind of a summary slide. If a coefficient is written in standard form or vertex form, the leading coefficient tells you whether it's either a happy face or a sad face. That's essentially what it does. So let me end with one last question. And then we'll give you guys some work time. Not that Dash 2 kids won't get asked this, but this one's a little bit more indicated for Jake. Which question was it that I told you to leave? Was it 3, D, and E?
D I just did because you showed us how to do it last time, and then E is the quadratic function which passes through 1/8 and has x in it.
Okay, so the question that you're referring to right there, this will help with some of you guys on the Dash 1 assignment a little bit. So let's do our last example here. Let's say that you've got yourself a parabolic archway, and I give you some measurements. From here to here is 280, and from here to here is 216. My question for you is, write me a quadratic equation that models this. So one of the last things I could ask you to do is I'll give you some characteristics, and rather than have me give you the equation, I want you guys to calculate the equation. So I'm going to graph this real quick first. Hopefully the graph would look something like that. Could you guys help me label a couple of points on the graph? Like, for example, this point right here,
0, 0.
which is this point right here. Yeah, 0, 0 makes a lot of sense, doesn't it?
Yeah. Nice have that.
What about right over here? That point would be right here. What would this point right here be labeled as?
280.
280 is 0, yeah. 280. 0. Okay, last one. What about the vertex?
260, whatever the half of 280 is.
Nice, yeah, you gotta do the right order though, because it's the 140 for the x value, and the 260.
I was going to say that, but I just wanted to throw you off.
As a general rule of thumb, if I give you some parameters about what a graph looks like, and one of them is the vertex, or you have like intercepts, you should be able to give me an equation. And this is one of the harder things to do. Rather than me give you the equation, and then you tell me properties, I could tell you properties and say, write me an equation. So that's what we're going to try now. In general, I can now write this in vertex form like this. Remember, vertex form goes like this. Y equals a leading coefficient, bracket, x minus h, I think was the one I used.
Yeah.
Whatever, it's a letter, who cares? Squared plus k. I need three values. I need to know my k value, I need to know my h value, and I need to know my a value. If I can find those three values, I'm done. Because x and y's have to like stay behind, right? Like you still have to have a y and an x value. So I'm really looking for three numbers. But I have a couple of them, don't I? What is the h value?
140.
Yeah, right? Because I have that number right there. The x was 140, but it's x minus 140 though, right? Don't make it x plus 140, x minus 140. I also have my k value. 216. I almost have my equation written. But I have one problem. I don't know my leading coefficient. And this is a skill that I need you guys to start building on now in grade 11, because we use it a lot in grade 12. It's the skill is, can you find a leading coefficient? Okay. Tell me something about this value. Is it going to be positive or negative?
Positive.
Negative.
Negative, actually. Well, why is it going to be negative, though?
Because it's a frowning face.
Because it's a frowning face, yeah. But here's the question. Is the value -2, -3, -4, -5.7, -11,023 over 421? I don't know what value it has, but I do know it's negative. So here's how you go about solving for that a value. We need this value, but I don't have it. Essentially, it's like a system of equations. I've got 1, 2, 3 variables I don't know, and this is the one I require. Here's the thing, though. I do know xy pairs on the graph. I know that 0 can go with 0, and I know that 280 can go with 0, and I even know that 140 can go with 216. So I don't really care which point I use. I probably don't use this one, though. This one causes issues. I'm going to plug in an xy pair off the graph I know is true, like say 0 and 0. So I'm going to say, well, y is 0 when x is 0. Makes sense? Like I have an x and a y combo. This 0 and this 0 can go together. And now what I found for myself is a way to isolate so that there's no remaining unknowns except for the a. So now I'm going to solve for a. So there's a little bit of algebra here. It's not a lot. Sorry. So it's 0 equals a times -140 squared. Right? Because 0 minus 140. 0 minus 140 is minus 140. When you square it, you get 19,600 plus 216. How do you get a by itself? I might say subtract the 216 to the other side, and then divide by 19,600. You're not going to like this part. but 9 times out of 10 when you solve for this a value, it's almost always a really ugly decimal fraction. It is what it is. If you were to take minus 216 then and divide by 19,600, that's not right. 19,600. Our leading coefficient is that value right there. 9 times out of 10 it's something gross.
Gross.
So here's the advice I give you. Just leave it as that fraction. So here's our final answer. If I want to write an equation for it, it gets written like this. Y equals, we need to know the a value. Well, now I finally know the a value. It is negative 216 over 19,600. Then I need my x minus my vertex point.
140.
140? Yes. Squared. And then I need to add the last number, which was 216. And now I have myself a equation. So for you guys in my dash 1 class, and even dash 2 guys, you will need to do this, so don't completely go, I don't care. But one of the skills I need you to possess is, if I give you data, can you write an equation? Most of the time, you need to solve for a leading coefficient. So what you end up doing is you take the data you're given, which is like the vertex right here, you write it in vertex form by plugging in the h and k, but you still don't know your a value. To find your a value, temporarily plug in a point on your graph, like say 0 and 0 would work. Solve for your a value, and then rewrite your equation. It sucks, because most of the time that value there is something dumb.
Yeah.
That being said, before we started, didn't we say it had to be negative? It is. That's a good sign. Okay, last thing. I'm not actually going to solve this one here, but if I asked you to find the height of the archway at a point that's 50 centimeters from its outer edge, all you'd do is type that graph in your calculator and find the value when x is 50.
That's a weird graph.
Well, you'd have to change your window size to make it work. But essentially, once you get this in your graphing calculator, find when x is 50 to see what y is equal to. All right. Is there any questions?
How do you get rid of pickups?
We'll do that. Okay. Quick summary then, guys. If you're in my dash 2 class, we're done. That's all we got for the unit. One type of function. Okay. If you guys are in dash 1, we have a few more lessons we're going to do where we learn about different types of graphs. But you guys, can I get your attention fully though? I'm almost done talking, I promise. What I want from you guys though is, let's try to stay on schedule, because I feel like a few of you have been a little loosey-goosey with finishing stuff on time, where you're still finishing up your stats or your patterns or radicals. So I'm going to start putting a few more hard deadlines on. I want you guys to